Hello, engineers. Hope you all are doing great. In today's session, we are going to discuss around databases. So, before directly moving to databases, let's discuss something called application deployment architecture. Application deployment architecture. So, what is this architecture? What is this architecture? This is nothing but it tells us about how the different applications of our infrastructure, or in other terms, what or how the different application or different related applications of our infrastructure are being deployed. So, let me write the definition here. It tells us about how the different applications or different related applications of our system infrastructure are deployed altogether. Now, what do we understand by different related applications? So, in our system or system infrastructure, we can have many applications running all together. One can be one can be our server, or more specifically, if we can have something called node server, or we can have a Spring server, or whatever server do you want. We can have um, databases, database, or we can have databases. We can have multiple databases, right? Database servers. We can have other services also, other services, right? So this application deployment architecture tells us how these different applications are being deployed all together, how these different applications are being deployed all together. So there are majorly two types of application deployment architectures. First one is stateful architecture. First one is what? It's a stateful architecture. And another one is stateless architecture. Stateless architecture. Architecture, right? Stateless architecture. Now let's discuss about stateful architecture. Let's discuss about stateful architecture. What is this? Why do we need this? Right? So, what is stateful architecture? Suppose I rented a AWS machine. I rented a AWS machine or EC2 machine. This is my, let's say, EC2 machine. Okay, let me write it here. This is my EC2 machine. EC2 machine. Now on this machine, what I will do, I will deploy my node server or any other server, Spring server, whatever server do you want. My node server, right? Node server. On this single machine only, if I deploy my database also, if I deploy my database also, right? This is my database. Then this architecture is stateful architecture. Why? Or why is it stateful architecture? Because we are having the database inside the same machine. Our server is being deployed. Our server is being deployed. So stateful architecture means that you have you have application server, application server, and inside the same machine you have, or you are trying to keep your DB. You are trying to keep your DB. This is stateful architecture. Like whenever you guys do any personal project, what you simply rent the EC2 machine. You simply rent the EC2 machine, and inside that machine only you deploy your application server and database and other services also, right? This is stateful architecture. This is stateful architecture. But this architecture has some challenges with it. It has some challenges with it. What are those? What are those? Suppose, let me shrink it a bit. Um, yeah, it's fine now, right? Suppose I have two such machines. Let's say I have two such machines. Okay, this one my machine one, and this is my machine two. Okay, now what will happen? What will happen? Suppose a user request first came to machine one, right? Server one, application server one. Then its corresponding data will be stored in this database only. In this database only, right? Now, whenever whenever the user request comes, the request from same user comes, we have to redirect it to same server because its related data is stored in this database only, right? What if this server or this machine got crashed? This machine got crashed. Then what will happen if the user request goes to this server? Then this server shall not be having, or this database shall not be having the appropriate data related to that user because that data was initially being stored in this database, right? In this database. So with stateful architecture, what are the challenges we have? First one is it's single point of failure. Single point of failure. Or can't say single point of failure. We can say that if one machine crashes, then all the data of the related clients will be lost. Will be lost, right? It will be lost. So it is the major challenge with this server. It's the major challenge with this server. Then you will ask me, then why are we having this architecture if there is challenge? So it's like in earlier days we didn't have much enough compute or what we say money to rent multiple machines or can have multiple machines, one individually for our application server and one individually for our database server. Also in initial days we had uh, slightly lesser, or not slightly, a significant lesser number of users in initial days. So our single machine was quite enough. Our single machine was quite enough. Or suppose we are doing any personal project, or we don't have a startup or application of too much scale, then we can follow this architecture. We need not to rent separate machines for application server and database server differently. So we can have this architecture, right? Then the another one is stateless architecture. Then the another one is stateless architecture. We write it here. Stateless architecture. Like, what does this architecture mean? It simply means you have a machine, right? You have a machine. This is my EC2 machine. Let's right. This is my EC2 machine. And on this machine, I have deployed my application server. I have deployed my application server. All good. All good. Then I have another machine. I have another machine on which my database is being deployed. database database is being deployed, right? And application server connects to database, right? Now, what is the benefit of having stateless architecture? What is the benefit of having stateless architecture? It's simply, suppose if I horizontally scales it, if I horizontally scales my application server, right? Then I need not to worry about that which server my client request should go to. Which server should my client request should go to? If it goes to this server, then this server will also be connecting with this single database only. And if the client request goes to this server, then this server will also be connecting to the same database. So it is the benefit of having stateless architecture. And in most of the application nowadays, you will see they usually follow stateless architecture. They usually follow stateless architecture, right? Okay, that's fine. So this was stateful architecture and this was stateless architecture. And see, since in stateful architecture we have to redirect the client request to the same server each time, we need to have the user data for it. Like like server has to retain user data. Server has to retain user data, like which user was redirected to which server. Which user was redirected to which server. So I can write it here in stateful architecture. Server retains the user data, or we can simply call it a session, right? Session. But in stateless architecture, server treats each request as individual new request, right? Server treats each request as individual new request. I can write it here as well. In stateless architecture, server treats each request as individual new request, right? New request. Okay, now we are done with the application deployment architecture. Like we can have a stateful architecture where our application server and database resides inside the same machine, and we can have stateless architecture. We can have stateless architecture where our database server is being deployed on a separate machine and our application server is deployed on a separate machine. In most of the applications, you will see stateless architecture nowadays. So we shall be having a discussion about stateless architecture. About stateless architecture. So whatever in this lecture or other lectures we shall be doing about scalability, we shall be considering stateless architecture only. Stateless architecture only, right? Now the question arises. Now the main question arises. Suppose we have only a single server. Remove this, right? Remove this also. We have a server. Okay. Now, if number of users increases or number of client requests increases, what we can do? What we can do? We need some mechanism to make our system or database system scalable. Make a database system scalable, right? Suppose there are somewhere around uh, 1 million users, right? And 5 terabytes of data, then queries will become slow, and like there are other challenges also. So what we can do, we need some mechanism to scale up our database. We need some mechanism to scale our database. So the question arises here is how to scale our database server. And one thing I would like to I would like to ask you all, do you guys understand what is meant by database server? What is database server? See, We have databases, right? We have MySQL, PostgreSQL, MongoDB, and other databases also. So database is kind of a physical storage, right? Database kind of a physical storage that is a uh, interface over physical storage. Our data is stored in a disk. Data is stored in disk. Disk is what our SBD or SSD, and database is simply a interface over it. A interface over it, right? But how we or our application server is able to access this database? Like it's like data is stored somewhere in a physical disk, right? And how our application server is able to access that data. So we need to deploy our database somewhere. We need to deploy our database survey somewhere. So where we shall be deploying our database? We shall be deploying our database over some machine, over some physical machine, right? We can do like rent a EC2 machine, AWS EC2, and deploy our database there. Or we can have cloud storages also. For example, MongoDB provides MongoDB Atlas, right? And PostgreSQL provides Supabase. We can do that thing. Also, AWS provides RDS, Relational Database System. We can do other those things also. So the main thing is that our database is being deployed on some physical machine, and that physical machine is called a database server. Database server. So let me write it here. Database server, right? Database server. What is this? What is database server? So database server is what? It is the physical machine over which our database is deployed. Database is deployed. Okay, so this is a database server. It's simply a machine. So when number of users or requests increases, it's simply a machine. Then it may at some time become incapable of handling that user load or that load, right? So we need to scale it up. We need to scale it up. So how can we do it? There are for scaling thing, we have two major approaches. We have two major approaches. You all know that if you are watching our previous lectures or any other lectures on YouTube or reading any articles. First one is what? Vertical scaling. Vertical scaling. Another one is what? Another one is horizontal scaling. Horizontal scaling. And we can have one more thing that we can implement, that is query optimizations. Query optimizations. Right? Query optimizations. So, in this lecture or in this video, we shall be discussing about vertical scaling and query optimization. Vertical scaling and query optimization. And in our upcoming videos, we shall be discussing horizontal scaling in detail. We shall be discussing horizontal scaling in detail. Okay. So let's come to vertical scaling. Let's come to vertical scaling. So what is meant by vertical scaling in terms of databases or database servers? It simply means increasing the capabilities of a single database server. It is increasing the capabilities of a single database server, right? What does it mean? Suppose initially our my SQL was hosted on a machine, EC2 machine. It was of 4 cores. Then I see increasing number of user load. Then I decided to upgrade it to 16 cores. I decided to upgrade it to 16 cores, right? Then again I see increasing number of user loads, right? Then I decided to have it's for 64 cores, sorry, 64 cores, right? So this is vertical scaling. It means increasing the capabilities of a single database server, not renting or not having multiple servers. It is increasing the capability of that single server only. Of that single server only, it is vertical scaling, right? Now, vertical scaling is good if you don't have too much user load, right? If initially you had somewhere around 10 lakhs of requests uh, per second. Now you are having 40 lakhs of requests per second. So you can do vertical scaling and you are sure that it can maximum go to 50 lakh requests per second, not more than that. Then in such case, vertical scaling is good for you. Vertical scaling is good for you. See, system design is not about perfection. System design is not about perfection. It's always about the trade-offs. Let me write it here. Let me write it here in a good fashion. System design is not about um write it here this way, right? System design is not about perfection. It's all about trade-offs, right? It's all about trade-offs. And in most of the cases, the trade-offs are between, in most of the cases, trade-offs are between what? The better infrastructure and the cost. In most of the cases, the trade-offs are between better infrastructure and cost. So it's not about perfection. What does it mean? It's not about perfection. Like if you want to make your system perfect, like I want uh, proper horizontal scaling and with the highest compute power I can have it. Okay. But your user load is not that high. Your user load is not that high. So you have to pay the more amount than you are gaining for the like suppose you got 10 machines 10 machines and each of 64 cores or more uh, memory, right? Then you have to eventually pay for it to AWS or any service you are getting. But your user load is not that high. So your revenue is not that high, but you are paying more. So what will happen? Your startup will crash. Not only your server will crash, your startup will crash, right? So it's all about perfection. It's not about perfection. It's about trade-offs between cost and what? Cost and making your infrastructure better. See, everyone in the world cannot have everything. In Hindi we say कि सबको सब नहीं मिलता because in world we don't have enough money कि सबको सब मिल जाए. In world we don't have enough money कि सबको सब मिल जाए. अगर ऐसा होता कि सबको सब मिल जाता तो इकोनॉमिक्स कभी एग्जिस्ट ही नहीं करती. इकोनॉमिक्स कभी एग्जिस्ट ही नहीं करती. तो द थिंग इज सबको सब नहीं मिलता. यू हैव टू थिंक अबाउट द ट्रेड ऑफ कि क्या आपके केस में सही रहेगा. द सेम अप्लाइज फॉर सिस्टम डिजाइन ऑल्सो. You have to carefully study your system and understand what is good for your system. What is good for your system. Okay. So coming back to vertical scaling, it's about increasing the capability of a single database server. Right. Now we have some challenges with it. We have some challenges with it. Let's discuss them. Challenges with vertical scaling, right? Challenges with vertical scaling. First one is First one is it's single point of failure. It's single point of failure. Like you had only single database machine, right? You had only single database machine and it crashed. It crashed. Then all your data is going to be lost. All your data is going to be lost. You can't do anything. So this is a one challenge with this. It's a single point of failure. And it has all the same challenges we discussed when we discussed about vertical scaling of data servers, right? It has all the challenges. But one additional challenge it can have is that when you buy when you buy new machine, new powerful machine, then you need to migrate whole data to that machine, right? Suppose you had 5 TB of data, 5 terabytes of data, and you decided to get a more powerful machine. So from this machine, you have to migrate all data to this, right? All data this. And when migrating, during migration, like it can take hours. It can take hours. While migrating, new data will generate. New data will generate. So it's again a drawback. It's again a drawback. Let me write it here also. That what about new data that comes while migrating, right? So this is a issue with, like there are multiple issues with vertical scaling. That's why that's why we require horizontal scaling. That's why we require horizontal scaling, about which we shall discuss in next video. We shall discuss in next video, and it will be a fun for you, right? Before that, let's discuss about query optimizations also. Query optimizations. And in query optimizations, we are going to discuss a very important topic, that is partitioning. That is partitioning. So let's start with query optimizations. Query optimization. What does query optimizations mean? What does query optimizations mean? It means it means querying to the database in a efficient manner, so that it takes the minimum possible time and compute power. Okay. So query optimization means like whenever you query to databases, like select that select star from users or whatever query, you have to make it in a optimistic way, so that compute time or compute resources are minimized and time is also get reduced. Okay. So there are various query optimization things you can do. First one is indexing. First one is indexing. You can do indexing. What is meant by indexing? Indexing, right? Suppose initially um you are owning a school. Let's say you are owning a school and it has 1 million students. Okay. Let's say it has 1 million students. So you would probably have a table. You would probably have a table, right? Would probably have a table. In this, let's say you are storing two fields. You are storing fields what? You are storing roll number and you are storing name of the student. Okay, name. Now, someone wrote a query. Someone wrote a query that looks something like select star from students where name equals to Z, where name equals to Z. Now, what will happen? A database will scan the whole table, will scan the whole table and return the student data where name is Z, where name is Z. So it has to iterate over all the 1 million users, all the 1 million rows, right? So what is the time complexity here? If you guys are interested in what we say, data structures and algorithm, what is the time complexity here? It will be order of n. It will be of order, like it has to scan all the rows here. So in indexing, what we do, as we see in books, right? In books, we have a index. In books, we have a index, and in that index, we have topics and their corresponding page numbers. We have topics and their corresponding page numbers. So in databases also we have a concept of indexing in which a separate file databases store the indexes of the particular rows of particular rows, right? Suppose it wrote it can be of any type. Suppose it can have like we have somewhere, wait, oh, this is the students table, students, right? And what is this? Don't know. Then it can have something like its student's name is starting from A, R, R is starting from this row, right? The student's name B is starting from B, R at this row, right? And so on, and so on. Okay, so it internally uses B tree. It internally uses B tree or B plus tree, and after applying indexing, after applying indexing, the time complexity reduced to order of log n, order of log n, right? So in, I guess, in our third video from here, I shall be having a hands-on where we shall be doing indexing. We shall be doing indexing in MongoDB, right? So indexing is a kind of a query optimization technique we can apply so that search space get reduced. Search space get reduced, right? This way search space will get reduced. Now suppose the name is dead. So from index we will get that dead starts from line number 796 and we will scanning from line 796 only, right? All other rows will be eliminated. So search space get reduced. Okay. Another method we can have is writing efficient queries, right? Writing efficient queries. Um, Writing efficient queries. Suppose there are two queries. First one is, hmm, sorry. First query says, select star from users. Suppose there is a user table and first query says select star from users. And there is another query that says select start from users where date can be any date, joining date, let's say joining date is greater than equals to any date 12 slash 12 slash 12 and joining date is less than equals to what 1 1 13, right? There can be now tell me which query will work in a better way. For this query it has to scan the whole table, right? It will give user from all tables and this query will return the uh, what we say will return only the users which are within this joining date, right? Which are within this joining date. So this query has relatively less search space. Okay. And we can have other things also like using lesser joins if possible. And we can have other mechanism also to write efficient queries. Then comes the important part which comes under query optimization only that we call partition. That we call partition. Partition. What is meant by partition? Partition simply means partition simply means it means dividing your dividing what am I writing? Dividing your data across multiple tables or partitions or like tables or partitions for reducing search space. Let's discuss how partition works. So partition is of two types. We can do partition of two types. First one is row based partitioning. First one is row based partitioning. Row based partitioning. And another one is column based partitioning. Column based partitioning. And we call column based partitioning as normalization. It's kind of a normalization also, right? So let's first understand what is meant by column based partitioning. What is meant by column based partitioning? Let me write it here. Column based partitioning. In this, what we do, suppose we have multiple attributes here. This is a table, database table, right? Okay, these are our database table. Now, in this, let's say we have name. We have name. We have department. We can have department. Okay. Called product, right? And I have something called price, product price, PP, product price, right? Suppose a customer A can have any department D1. He buys a product P1. Okay. P1 and it has cost 80,000, right? 80,000. 8,000. Okay. Now the same person A, he belongs to same department D1. He bought some product P2, right? And it costs him or her 6,000, let's say. And another person A belongs to same department, right? Bought some product P3, it cost him 5,000, okay, right? And suppose he bought 10 more such products, okay, 10 more such products, 10 total products, let's say. Now you will see that what will happen that in this table, this name, this department is getting redundantly stored, right? Is getting redundantly stored. Like for those 10 times, I will get this same department. I will get this same department. I will get the same name. I will get the same name. Else, what I can divide this data into multiple columns. I can divide this data into multiple columns or multiple tables. Let's say I created a one table. I created a one table in which I am storing I am storing user ID, UID, his or her name or department, right? And department. And in another table, let's copy this one only. Um, Control C, Control V. In another table, I am storing user ID, product he or she purchased, and product price, right? Product price. Now, what I will have to do, I will simply store user ID 1, name A, name A, and department D1, department D1. And whenever he purchases a new item, I will simply do 1 product P1, price 8,000, 8,000, right? Then again, uh, same user ID. Now this time product P2 and price is 6,000 and multiple such products. Okay. Now you will see what happened here that earlier my department and name was getting stored multiple times redundantly. Okay. After I did normalization or I moved my data to multiple tables, the redundancy reduced. The redundancy got reduced. I have to store the name and department only once, right? So in cloud based, in column based partitioning, which we also call normalization, we divide our data based on columns, and it is more for reducing redundancy than reducing search time. Let me write it here. Column based partitioning is more for reducing redundancy Then search optimization. Okay. So this was column based partitioning. Let's come to our main topic, that is row based partitioning. That is row based partitioning. Let's write it here. Row based partitioning. Okay. Now, the one thing that you have to keep in mind for partition, that it is within the same server. It is within the same server. And let's modify this definition as well. It means dividing your data across multiple tables, partitions, or reducing search space within same database server. And let me highlight it as well. This is the main difference between partitioning and sharding. Most people interchangeably use them, but they are actually different. Um, that's fine. So partitioning means dividing the data across multiple tables, but within the same server. We are not renting new servers. We are not renting new servers. That's about horizontal scaling when we have multiple servers. But within the same server, within the same database server, we divide our data across multiple tables. Across multiple tables. Now, in row-based partitioning, what happens that suppose I do something called I have mhm, 1 million users. So what I will do, I will store 0 to first 10,000 users in table 1, right? Then 1001 to, sorry, 10,001 to 20,001 users in table 2. Then so on. Then so on. So on. So from the same that data only, suppose I had this data and it had 1 million user rows. It has 1 million users. It was about user data like ID, name, department, and all such things. Let's say. So what I will do for partitioning, what I will do for partition, I will divide this. I will divide this into multiple. Suppose s- these rows in one table, these rows in one table, and these rows in one table. These rows in one table. So what will happen this way? What will happen this way? First thing that will improve for sure is searching space will be smaller. Searching space will be smaller, right? Suppose earlier you have to find a user. So you have to go through all the 1 million users. Now you got its ID. That ID is 500. So you are sure that you will get him or her somewhere in the table one. In the table one, because table one stores users with ID between ID 0 and 10,000. So a user with user ID 500 will be found in table one. So the searching space will get reduced, right? Earlier you have to search among these 1 million users. Now you have to search among these 10,000 users only. One more thing that will improve is you can search multiple partitions separately. You can search multiple partitions separately, or like parallel processing kind of thing. parallel processing, right? In this way, you will be able to parallelly search for different users. Suppose I have multiple queries and I have to find about 10 users that belongs to 10 different tables, 10 different tables. So I can parallelly search between these tables, right? I can parallelly search in these 10 tables. So I can do parallel processing also. So it was partitioning. Now you can ask me that what is partition? What is partition? What is partition? Is it any physical space or what? See, uh, partition is nothing but in relational databases, we can call our multiple tables a partition, right? Suppose I create three more tables from this table only, three more tables from this table only, then each that table will be a partition. Then each table will be a partition, right? Like there will be no physical segregation, but we will call that table as new partition only. Okay. Suppose we have MongoDB, we have documents and collections. So I create a new collection in that. So each new collection will be called a partition. It will be called a partition, right? So it was all for today's lecture. In today's lecture, we first discussed about application deployment architecture, right? We discussed about stateful architecture and stateless architecture. In stateful architecture, we deploy our application server and database server in the same machine. Then we discuss about the challenges with it, right? If you have application server inside the same machine, what were the challenges? If one machine crashes, then all of the data will be lost, right? All of the data will be lost. Then we discuss about stateless architecture. In stateless architecture, what we usually do, we keep our database and application server separate in separate machines. Separate in separate machines. Most of the architectures nowadays follows stateless architecture. So we started discussing about stateless architecture. How can we scale it up? So the question arose that how to scale our database server. So database server is what? It is the physical machine over which database is deployed. To scale our database server, we usually have two major approaches. First one is vertical scaling and another one is horizontal scaling. But we can have query optimization also. We can have query optimizations also. In vertical scaling, we discussed that we can increase the capability of our single database. Then we discuss about challenges with it. Like if you buy a new powerful machine, you have to migrate all your existing data to that new machine, right? Then we discussed about query optimization techniques. We discussed about indexing. What is indexing? For indexing, I shall be uploading a complete end-to-end video in which I will discuss indexing and give you a hands-on over indexing. Right. So we discussed about indexing. We discussed about writing efficient queries, that we should write efficient queries to make our database more search optimized or optimized. Then we came to the main topic, that is partition. We discussed that partition is dividing our data across multiple tables or partitions, but within the same database server, within the same database server, right? If we have multiple database server, we call it sharding, not partition. And we had two approaches to partitioning. First one is row-based partitioning, and another one is column-based partitioning. Column-based partitioning is nothing but normalization only. We divide our data based on columns, so to reduce this redundancy. Then we discussed about row-based partitioning, in which we divide our data based on rows, right? So let's end today's lecture here. Let's meet you all in the next set of lectures. Until then, keep learning, keep exploring. Bye bye.